Welcome to the 13th tutorial. We're going to be starting on machine learning. Welcome. Please like, share, and subscribe.
In this section, you're going to learn about machine learning, which is a subset of AI or artificial intelligence. It's one of the trending topics in the world these days, and it's going to have a lot of applications in the future. Here's an example. Imagine I ask you to write a program to scan an image and tell if it's a cat or a dog. If you want to build this program using traditional programming techniques, your program is going to get overly complex. You will have to come up with lots of rules to look for specific curves, edges, and colors in an image to tell if it's a cat or a dog. But if I give you a black and white photo, your rules may not work. They may break. Then you'll have to rewrite them. Or I may give you a picture of a cat or a dog from a different angle that you did not predict before. So solving this problem using traditional programming techniques is going to get overly complex or sometimes impossible. Now, to make the matter worse, what if in the future I ask you to extend this program such that it supports three kinds of animals: cats, dogs, and horses? Once again, you'll have to rewrite all those rules. That's not going to work. So, machine learning is a technique to solve these kind of problems. And this is how it works. We build a model or an engine and give it lots and lots of data. For example, we give it thousands or tens of thousands of pictures of cats and dogs. Our model will then find and learn patterns in the input data, so we can give it a new picture of a cat that it hasn't seen before and ask it, is it a cat or a dog or a horse? And it will tell us with a certain level of accuracy. The more input data we give it, the more accurate our model is going to be. So that was a very basic example. But machine learning has other applications in self driving cars, robotics, language processing, vision processing, forecasting things like stock market trends and the weather, games, and so on. So that's the basic idea about machine learning. Next, we'll look at machine learning in action. A machine learning project involves a number of steps. The first step is to import our data, which often comes in the form of a CSV file. You might have a database with lots of data. We can simply export that data and store it in a CSV file for the purpose of our machine learning project. So we import our data. Next, we need to clean it. And this involves tasks such as removing duplicated data. If you have duplicates in the data, we don't want to feed this to our model because otherwise our model will learn bad patterns in the data and it will produce the wrong result. So we should make sure that our input data is in a good and clean shape. If there are data that is irrelevant, we should remove them. If they're duplicated or incomplete, we can remove or modify them. If our data is text-based, like the name of countries or genres of music or cats and dogs, we need to convert them to numerical values. So this step really depends on the kind of data we're working with. Every project is different. Now that we have a clean data set, we need to split it into two segments, one for training our model and the other for testing it to make sure that our model produces the right result. For example, if you have 1,000 pictures of cats and dogs, we can reserve 80% for training and the other 20% for testing. The next step is to create a model, and this involves selecting an algorithm to analyze the data. There's so many different machine learning algorithms out there, such as decision trees, neural networks, and so on. Each algorithm has pros and cons in terms of accuracy and performance. So the algorithm you choose depends on the kind of problem you're trying to solve and your input data. Now, the good news is that we don't have to explicitly program an algorithm. There are libraries out there that provide these algorithms. One of the most popular ones, which we're going to look at in this tutorial, is scikit-learn. So we build a model using an algorithm. Next, we need to train our model. So we feed it our training data. Our model will then look for the patterns in the data. So next, we can ask it to make predictions. Back to our example of cats and dogs, we can ask our model, is this a cat or a dog? And our model will make a prediction. Now, the prediction is not always accurate. In fact, when you start out, it's very likely that your predictions are inaccurate. So we need to evaluate the predictions and measure their accuracy. Then we need to get back to our model and either select a different algorithm that is going to produce a more accurate result for the kind of problem we're trying to solve, or fine tune the parameters of our model. So each algorithm has parameters that we can modify to optimize the accuracy. So these are the high level steps that you follow in a machine learning project. Next, we'll look at the libraries and tools for machine learning. In this lecture, we're going to look at the popular Python libraries that we use in machine learning projects. The first one is NumPy, which provides a multi-dimensional array. Very, very popular library. The second one is Pandas, which is a data analysis library that provides a concept called data frame. A data frame is a two-dimensional data structure similar to an Excel spreadsheet. So we have rows and columns. We can select data in a row or a column or a range of rows and columns. Again, very, very popular in machine learning and data science projects. The third library is Matplotlib, which is a two-dimensional plotting library for creating graphs and plots. The next library is scikit-learn, which is one of the most popular machine learning libraries that provides all these common algorithms like decision trees, neural networks, and so on. Now, when working with machine learning projects, we use an environment called Jupyter for writing our code. Technically, we can still use VS Code or any other code editors, but these editors are not ideal for machine learning projects because we frequently need to inspect the data, and that is really hard in environments like VS Code and Terminal. If you're working with a table of 10 or 20 columns, visualizing this data in a terminal window is really, really difficult and messy. So that's why we use Jupyter. It makes it really easy to inspect our data. Now, to install Jupyter, we're going to use a platform called Anaconda. So head over to anaconda.com/download. On this page, you can download Anaconda distribution for your operating system. So we have distributions for Windows, Mac, and Linux. So let's go ahead and install Anaconda for Python 3.7. Download. All right, so here's Anaconda downloaded on my machine. Let's double click this. All right, first it's going to run a program to determine if the software can be installed. So let's continue. And once again, continue, continue. Pretty easy. Continue one more time. I agree with the license agreement. Okay. You can use the default installation location, so don't worry about that. Just click install. Give it a few seconds. Now, the beautiful thing about Anaconda is that it will install Jupyter, as well as all those popular data science libraries like NumPy, Pandas, and so on. So we don't have to manually install this using pip. All right, now as part of the next step, Anaconda is suggesting to install Microsoft VS Code. We already have this on our machine, so we don't have to install it. We can go with continue and close the installation. Now, finally, we can move this to trash because we don't need this installer in the future. All right, now open up a terminal window and type Jupyter with a Y space notebook. This will start the notebook server on your machine. So enter. There you go. This will start the notebook server on your machine. You can see these default messages here. Don't worry about them. Now it automatically opens a browser window pointing to localhost port 8888. This is what we call Jupyter dashboard. On this dashboard, we have a few tabs. The first tab is the Files tab, and by default, this points to your home directory. So every user on your machine has a home directory. This is my home directory on Mac. You can see here we have a desktop folder as well as documents, downloads, and so on. On your machine, you're going to see different folders. So somewhere on your machine, you need to create a Jupyter notebook. I'm going to go to desktop. Here's my desktop. I don't have anything here. And then click new. I want to create a notebook for Python 3. In this notebook, we can write Python code and execute it line by line. We can easily visualize our data, as you will see over the next few videos. So let's go ahead with this. All right, here's our first notebook. You can see by default, it's called Untitled. Let's change that to Hello World. So this is going to be the Hello World of our machine learning project. Let's rename this. Now, if you look at your desktop, you can see this file, helloworld.ipynb. This is a Jupyter notebook. It's kind of similar to our Py files where we write our Python code, but it includes additional data that Jupyter uses to execute our code. So back to our notebook, let's do a print hello world. And then click this run button here, and here's the result printed in Jupyter. So we don't have to navigate back and forth between the terminal window. We can see all the result right here. Next, I'm going to show you how to load a dataset from a CSV file in Jupyter. All right, in this lecture, we're going to download a dataset from a very popular website called Kaggle.com. Kaggle is basically a place to do data science projects. So the first thing you need to do is to create an account. You can sign up with Facebook, Google, or using a custom email and password. Once you sign up, then come back here on kaggle.com. Here in the search bar, search for video game sales. This is the name of a very popular data set that we're going to use.
Okay, I just want to pause it real quick. Um, so I'm just gonna take it some steps. So you're gonna go to anaconda.com, download the Jupyter program, and then you're gonna go to kaggle.com and then look for video game sales. Now, this is kind of, I'm going through this process, so you'll probably have to actually go back and download all the stuff because that's actually what I'm going to do. So you're going to have to obviously do this in your own time because I'm literally doing this live as we go. So as you know, I'm learning, we're all learning, and you know, there's certain programs that obviously we need to download. So go ahead and, you know, on your own time, if you can, download these programs. Um, Unfortunately, right now, I just don't have a lot of time to kind of do updated videos. Once I get more time, I'll probably create a playlist and then go back and do some updated videos for those in the future that are having some issues on a PC because this is looks like it's more Mac related here. But if I have time, I will do an updated video. But in the interim, go ahead and download these programs. But we're going to go ahead and just continue watching the video.
In this lecture. So here in this list, you can see the first item with this kind of reddish icon. So let's go with that. As you can see, this data set includes the sales data for more than 16,000 video games. On this page, you can see the description of various columns in this data set. We have rank, name, platform, year, and so on. So here's our data source. It's a CSV file called vgsales.csv. As you can see, there are over 16,000 rows and 11 columns in this data set. Right below that, you can see the first few records of this data set. So here's our first record. The ranking for this game is 1. It's the Wii Sports game for Wii as the platform, and it was released in year 2006. Now, what I want you to do is to go ahead and download this data set. And as I told you before, you need to sign in before you can download this. So this will give you a zip file, as you can see here. Here's our CSV file. Now, I want you to put this right next to your Jupyter notebook. On my machine, that is on my desktop. So I'm going to drag and drop this onto the desktop folder. Now, if you look at the desktop, you can see here's my Jupyter Hello World notebook. And right next to that, we have vgsales.csv. With that, we go back to our Jupyter notebook. Let's remove the first line and instead import pandas as PD. With this, we're importing pandas module and renaming it to PD so we don't have to type pandas dot several times in this code. Now let's type PD dot read underline CSV and pass the name of our CSV file. That is vgsales.csv. Now, because this CSV file is in the current folder right next to our Jupyter notebook, we can easily load it. Otherwise, we'll have to supply the full path to this file. So this returns a data frame object, which is like an Excel spreadsheet. Let me show you. So we store it here, and then we can simply type df to inspect it. So one more time, let's run this program. Here's our data frame with these rows and columns. So we have rank, name, platform, and so on. Now, this data frame object has lots of attributes and methods that we're not going to cover in this tutorial. That's really beyond the scope of what we're going to do. So I leave it up to you to read Pandas documentation or follow other tutorials to learn about Pandas data frames. But in this lecture, I'm going to show you some of the most useful methods and attributes. The first one is shape. So shape, let's run this one more time. So here's the shape of this data set. We have over 16,000 records and 11 columns. Technically, this is a two-dimensional array of 16,011. Okay? Now, you can see here we have another segment for writing code. So we don't have to write all the code in the first segment. So here in the second segment, we can call one of the methods of the data frame, that is df.describe. Now, when we run this program, we can see the output for each segment right next to it. So here's our first segment. Here we have these 3 lines, and this is the output of the last line. Below that, we have our second segment. Here we're calling the describe method. And right below that, we have the output of this segment. So this is the beauty of Jupyter. We can easily visualize our data. Doing this with VS Code and terminal windows is really tedious and clunky. So what is this describe method returning? Basically, it's returning some basic information about each column in this data set. So as you saw earlier, we have columns like rank, year, and so on. These are the columns with numerical values. Now, for each column, we have the count, which is the number of records in that column. You can see our rank column has 16,598 records, whereas the year column has 16,327 records. So this shows that some of our records don't have the value for the year column. We have null values. So in a real data science or machine learning project, we'll have to use some techniques to clean up our data set. One option is to remove the records that don't have a value for the year column, or we can assign them a default value. That really depends on the project. Now, another attribute for each column is mean. So this is the average of all the values. Now, in the case of the rank column, this value doesn't really matter, but look at the year. So the average year for all these video games in our data set is 2006. And this might be important in the problem we're trying to solve. We also have standard deviation, which is a measure to quantify the amount of variation in our set of values. Below that, we have min. As an example, the minimum value for the year column is 1980. So quite often when we work with a new data set, we call the describe method to get some basic statistics about our data. Let me show you another useful attribute. So in the next segment, let's type df.values. Let's run this. As you can see, this returns a 2-dimensional array. This square bracket indicates the outer array, and the second one represents the inner array. So the first element in our outer array is an array itself. These are the values in this array, which basically represent the first row in our data set. So the video game with ranking 1, which is called Wii Sports. So this was a basic overview of Pandas data frames. In the next lecture, I'm going to show you some of the useful shortcuts of Jupyter. In this lecture, I'm going to show you some of the most useful shortcuts in Jupyter. Now, the first thing I want you to pay attention to is this green bar on the left. This indicates that this cell is currently in the edit mode, so we can write code here. Now, if we press the escape key, green turns to blue, and that means this cell is currently in the command mode. So basically, the activated cell can be either in the edit mode or the command mode. Depending on the mode, we have different shortcuts. So here we're currently in the command mode. If we press H, we can see the list of all the keyboard shortcuts. Right above this list, you can see macOS modifier keys. These are the extra keys that we have on a Mac keyboard. If you're a Windows user, you're not going to see this. So as an example, here is the shape of the command key. This is Control, this is Option, and so on. With this guideline, you can easily understand the shortcut associated with each command. Let me show you. So here we have all the commands when a cell is in the command mode. For example, we have this command, open the command palette. This is exactly like the command palette that we have in VS Code. Here's a shortcut to execute this command. That is Command, Shift, and F. Okay, so here we have lots of shortcuts. Of course, you're not going to use all of them all the time, but it's good to have a quick look here to see what is available for you. With these shortcuts, you can write code much faster. So let me show you some of the most useful ones. I'm going to close this. Now, with our first cell in the command mode, I'm going to press B, and this inserts a new cell below this cell. We can also go back to our first cell, press Escape. Now the cell is in the command mode. We can insert an empty cell above this cell by pressing A. So either A or B. A for above and B for below, okay? Now, if you don't want this cell, you can press D twice to delete it, like this. Now, in the cell, I'm going to print a hello world message. So, print hello world. Now, to run the code in this cell, we can click on the run button here. So, here's our print function, and right below that, you can see the output of this function. But note that when you run a cell, this will only execute the code in that cell. In other words, the code in other cells will not be executed. Let me show you what I mean. So in the cell below this cell, I'm going to delete the call to the describe method. Instead, I'm going to print ocean. Now, I'm going to put the cursor back in this cell where we print the hello world message and run this cell. So you can see hello world is displayed here, but the cell below is still displaying the describe table, so we don't see the changes here. Now, to solve this problem, we can go to the cell menu on the top and run all cells together. This can work for small projects, but sometimes you're working with a large data set, so if you want to run all these cells together, it's going to take a lot of time. That is the reason Jupyter saves the output of each cell, so we don't have to rerun that code if it hasn't changed. So this notebook file that we have here includes our source code organized in cells, as well as the output for each cell. That is why it's different from a regular Py file where we only have the source code. Here we also have auto-completion and IntelliSense. So in this cell, let's call df data frame dot. Now, if you press tab, you can see all the attributes and methods in this object. So let's call describe. Now, with the cursor on the name of the method, we can press shift and tab to see this tooltip that describes what this method does and what parameter it takes. So here in front of signature, you can see the describe method. These are the parameters and their default value. And right below that, you can see the description of what this method does. In this case, it generates descriptive statistics that summarize the central tendency and so on. Similar to VS Code, we can also convert a line to comment by pressing Command and slash on Mac or Control slash on Windows, like this. Now this line is a comment. We can press the same shortcut one more time to remove the comment. So these were some of the most useful shortcuts in Jupyter. Now, over the next few lectures, we're going to work on a real machine learning project. But before we get there, let's delete all the cells here. So we start with only a single empty cell. So here in this cell, first I'm going to press the escape button. Now the cell is blue, so we are in the command mode, and we can delete the cell by pressing D twice. There you go. Now the next cell is activated and it's in the command mode. So let's delete this as well. We have two more cells to delete. There you go. And the last one, like this. So now we have an empty notebook with a single cell. Over the next few lectures, we're going to work on a real machine learning project. Imagine we have an online music store. When our users sign up, we ask their age and gender, and based on their profile, we recommend various music albums they're likely to buy. So in this project, we want to use machine learning to increase sales. So we want to build a model. We feed this model with some sample data based on the existing users. Our model will learn the patterns in our data, so we can ask it to make predictions. When a new user signs up, we tell our model, hey, we have a new user with this profile. What is the kind of music that this user is interested in? Our model will say jazz or hip hop or whatever. And based on that, we can make suggestions to the user. So this is the problem we're going to solve. Now back to the list of steps in a machine learning project. First, we need to import our data. Then we should prepare or clean it. Next, we select a machine learning algorithm to build a model. We train our model and ask it to make predictions. And finally, we evaluate our algorithm to see its accuracy. If it's not accurate, we either fine-tune our model or select a different algorithm. So let's focus on the first step. Head over to bit.ly/music-csv. This is a very basic CSV that I've created for this project.
All right, so we're going to pause there. Go to hp//bit.ly/music /CSV. All right.
It's just some random made up data. It's not real. So we have a table with 3 columns.
Okay. So we're going to go ahead and pause there. So go ahead, download all the information that you need from this video. So go to anaconda.com and download the Jupyter program. So you can start importing some of this information, and then go to that bit.ly link. I'll go ahead and put this in the description so those who follow on the replay will know what they will need to download. But if you are watching this video before we get into tutorial 14, go ahead and download all the software. So by the time you get to tutorial 14, we'll be ready to go to start this machine learning project. All right, on that note, thanks for joining. Please like, share, and subscribe. And I guess we'll be seeing you for tutorial 14. Take care.